Hi guys, so in this welcome to the channel Code by Raghav. In this video we are going to solve the lead code question number 560, that is subarray sum equals k. It is a very interview popular question and it's a medium type question and it has been asked in many interviews. So for example in country, as you can see, there are many major companies available here: Amazon, Adobe. These are big names listed here that has asked this question in their interviews. LinkedIn, Microsoft, Google, Apple, Bloomberg, PayPal, Morgan Chase, Cisco, Disney, Flipkart, AMD, Walmart, and around hundreds of six, 50 companies. So let's read the statement of this question and let's try to solve it and how can we solve it. So, so we have given an array nums and an integer k. Return the total number of subarrays whose sum equals to k. A subarray is a contiguous non-empty sequence of elements within an array. Let me see if there is any follow-up question. So you can do this question by O of n square complexity by using the nested loops. So we are not going to use that approach. It's a brute force approach and it might be fail. I haven't tried it, but so it's not a good approach. And what we have to do, we have given an array nums and k is equal to 2, and we have to find the subarray, that's the subarray sum that is equals to k. So in the example we can see that there are only two subarrays, that is one subarray is this and another one subarray is this. Their sum is equal to k. Here you can see that k is equal to 3, so one is subarray this and the 3 is alone also a subarray. So let's see how can we solve that question. We are going to use the prefix sum strategy. Let me write the example right here. If you can see, if the total sum of this subarray from 0 to n minus 1, that is sum is 3, and if this if this is the length of this subarray is 2, so what will be the length of this subarray? That is 1. Obviously 3 minus 2, that is 1. So we are going to use the simple maths. So what we gonna do, we will take a sum and equals sum initialized by 0, and we will take a hash map right here. We will find in map if mp of sum minus k is present in this map or not. If it is present, then we will increase the count. What we have to return? We have to return the total number of subarrays, means the count of subarrays whose sum is equals to k. So let's try to dry run this example. Let's say 1 1 1. Count is initially 0 and sum is initially 0, and we will run a loop. We will iterate this array from 0 to n minus 1. Let me write the indexing also: 0 1 2. We will run the loop here and we will keep increasing our sum as we visit the each element. So the sum will come here the sum will become 0 plus 1, that is 1. Now sum is 1. Now we will check mp dot find. MP is our unordered map. Let me write it. It is a map. You can take any map. Unordered map is fast. Unordered map mp dot find. What are we going to find? Is sum minus k is present is here or not? And let me draw a subarray. Is sum minus k means what is our k? K is 2. This has been given in input. So sum is currently 1 and the k is minus 2. K is 2. So the sum becomes minus 1. Is minus 1 present in your map? Unordered map, hash map? No, it is not. So it is not present. So we will move it further. We will move the iteration further. Before moving further, we will store this sum that we have seen this sum over one time. So we will store the sum mp of sum plus plus. So we have seen this sum. So we will increase this sum count. So the sum is 1 and so this is the sum and this is the count. So 1 1 we have written. Next the I will come here. Now the sum become 2. 1 plus 1 2 and if we write 2 minus 2 that is equal to 0. Did we see the 0 inside the hash map? No, we have not. So what we will do? MP of sum plus plus, that is 2 1. If you carefully look at the input, this was our subarray whose sum is equals to k and we are ignoring it. We are not increasing our count of number of subarrays whose sum is equals to k. So that's the bug in our case, because we are starting from this array from start and we have not initialized for this 0 from this 0 sum 0 count. So this is a corner case. So what we will do when we write when we are initializing the variables, initializing the map, so we will already write mp of 0 is always be 1. So mp of 0 will always be 1. Then what the map becomes? This is our map. We will initialize it the 0 as 1 count. Then we got the 1 as 1 count. Now as you can see we have find the 0. Did we see 0 in our hash map? We will check. Is there any 0 in the hash map? Yes, there is a 0. So what we will do? Let me we will increase the count by which how many times we have seen means the count of the sum. So what is it? MP of sum minus k. So what is it? It is 1 and we will increase the count by 1 and this will also increase. The sum is currently 2, so 2 will count increase to 1. Now our I will come here at the second index. Now the sum becomes 3. Now we will check 3 minus k, that is 2, equal to 1. Did we see 1 inside our hash map? Yes, we have seen the 1 inside the hash map. So we will increase the count by how many times did we see? It is 1 time. So we will increase the count by 1 time. So count will become 2 and we will increase the 3 sum count. So it will become 1 and our I will go over the loop, means out of the array, and our code has been finished and we will return the count, that is 2, and that's what our answer is. If you can see, its input is 2. So let's try to solve it quickly. It is very simple. Let's calculate the size first, and we will take a unordered map, because if we take an ordered map it doesn't matter, we have just to find mp, and we will take and we will initialize the 0 sum count, that is mp of 0, that is 1, and we will take a count variable and we will take a sum variable that is initialized by 0. Let's iterate over this array. 0 less than n I plus plus, and let's increase the sum as we visit each element, nums of I, and if we will find inside our hash map that sum minus k is not equal to the mp of n, means it is present inside our hash map. So what we will do, we will increase the count by number of times how we have seen this sum, so that is n sum minus k, and we will also add the sum in our hash map, also add the count of this map and return the count. So let's try to run it, and our test case is passed. Let's try to submit it. Test cases was also passed, and let's calculate the time complexity. If you can see, it is running O of n times this for loop and mp dot find takes O of 1, so it doesn't matter. So the time complexity will become the O of n, and the space complexity, we are using an hash map of the size n, so it will be O of n. So that will be our time complexity and space complexity. If you like the video, thank you for watching. Please make sure like, share and subscribe. Watch out my other playlist also, interview questions for array. Thank you for watching. Thank you.